let's talk about percent composition of compounds. So, a list of the percent by mass of each element in a compound is known as the compound's percent composition by mass. So, each compound is made up of multiple different elements, and we can find the percentage that each element takes up in that molecule by finding its percent composition. To do this, we are going to follow this equation here. The percent by mass of a specific element is equal to N multiplied by the atomic mass of the element divided by the molecular mass of the compound overall multiplied by 100. Here, N is the number of atoms of the element in the compound. Make that CMPD in the compound. The atomic mass is from the periodic table, and the molecular or formula mass we have to calculate using our masses. So just what we were doing before. Those are all of our molecular and formula masses. So we're going to take the number of atoms of each element, multiply it by its atomic mass, divide it by the total mass of the compound, and then multiply it by 100 in order to get a percent. We have to multiply by 100 in order for it to be in terms of percentage. So let's look at an example of that. So let's determine the percent composition of hydrogen peroxide, H2O2. So the first thing that you want to do with all of these problems is determine the molecular mass, because that's the value that you're going to use in the denominator of these problems. So to find the molecular mass of H2O2 of hydrogen peroxide, we're going to take 2 times the mass of hydrogen, add to that 2 times the mass of oxygen. So we'll do that here. And we get that the molecular mass is 34.02 AMUs. Now we want to use the atomic mass of each element to determine the percent composition. So we have to do this for each element in the compound. So let's start with hydrogen. We know that there are 2 hydrogen atoms in this, so N is going to equal 2. So to solve this, we then take 2 times the atomic mass of the element, which is hydrogen, 1.01, divided by the mass, overall mass of the compound, which is 34.02, and then we multiply that by 100. So we take 2 times 1, can't type today, 1.01, and we're going to divide that by 34.02, the mass that we just determined. Now we're not done yet, that's not our final answer. We have to multiply by 100 to make it a percentage. So we have 5.94%. So hydrogen makes up about 6% of hydrogen peroxide's mass. Because it's very small, it's very light, it doesn't take up a lot of space. So it only makes up 6% of hydrogen peroxide's mass. If we look at oxygen, that also has 2 atoms. So N is equal to 2. So now we're going to take 2 times the mass of oxygen and divide it by the total mass of hydrogen peroxide and multiply that by 100. So we're going to take 2 times 16 and divide that by 34.02. And then we multiply by 100. Never forget to multiply by 100. So that gives us a percentage of 94.06%. So oxygen makes up 94% of hydrogen peroxide's mass. It's the heavier of the 2 atoms, so it makes sense that it takes up more of that mass. Okay, so And these are the percentages, the percent composition of hydrogen peroxide, of both hydrogen and oxygen in hydrogen peroxide. So we do the part over the whole. Part is how much of that individual atom, over the whole is the total mass. So let's keep practicing. What is the percent by mass of carbon in glucose, C6H12O6? Well, we found that molar mass before, so I'll save that step for you. That molar mass, or that atomic mass, I should say, is 180.18 AMUs. So don't recalculate that. We already calculated it before. So now determine the percent by mass of carbon in glucose. And you have your 4 options there to compare your work to. So from our equation on our previous slides, N in this case is equal to 6 because there are 6 atoms of carbon in this molecule. So we take 6 times the mass of carbon, 12.01, and we divide that by the total mass of glucose, 180.18, and multiply it by 100. So we take 6 times 12.01, the mass of carbon, divide that by our total mass of glucose, and multiply that by 100. So we get 39.993, so let's call that 40%, which is answer A. You could also find the mass percent of both hydrogen and oxygen as well, and you'll know if you're right or wrong if all of those percentages equal 100%. Because they all make up that total mass. Okay, let's keep it going. Let's calculate the percent by mass of iron in FeCl3. So the first thing that we want to do is find the mass of iron 3 chloride. This is iron 3 chloride. I'll name things as we go. Okay. So iron 3 chloride, we take the mass of iron, 55.85. We add to that 3 times the mass of chlorine, and we get 55.85 plus 3 times 35.45, and get 162.19 AMUs. So to calculate the percent by mass of iron, we take the mass of iron, 55.85. There's only one of them in the compound. There's only one iron atom, so we don't need to multiply it by anything. You could technically multiply it by 1 if you wanted to. Okay, not going to change it. And we divide it by the total mass of the compound, 162.19 AMUs. So we take I typed that in wrong. 8485, doesn't matter. I typed it in wrong, that's okay. Divide it by 162.19. Multiply that by 100, which I didn't show here. Multiply by 100. And we get a percentage of 34.43%. Next up, let's calculate the percent by mass of carbon in C6H10O4. So what I want you to do is pause this video, calculate the atomic mass of C6H10O4, and then try to find the percent by mass of carbon in that compound. I calculated my mass of C6H10O4 to be 146.16. Okay, I'll skip typing that into our calculator since we've done that so far multiple times. So we then take 6 times the mass of carbon, 12.01, and we divide that by the mass of the compound, 146.16, and we multiply that by 100. So we get 6 times 12.01 divided by 146.16. We multiply that by 100 to make it a percentage. We get 49.30%. So the carbon makes up about half of the mass of this compound. Okay, let's do a few more. Practice makes perfect. If you're getting this concept, feel free to pause the video, practice these on your own notepad, okay, and then use my video as a way to check your work to make sure you did it correctly. So our next example says, tin exists in the Earth's crust as SnO2. Determine the percent composition by mass of both tin and oxygen in SnO2. Tin oxide. That's tin 4 oxide. Okay, so the first thing we want to do is find the mass of tin 4 oxide. So we take the mass of tin, which is 118.71, add that to 2 times the mass of oxygen, and we get, let's see, 118.71 plus 2 times 16, we get 150.71. Okay, so now that we know the total mass, we can do tin first, and we take the 118.71. There's only one tin in there, so we don't need to multiply it by anything. We divide it by the total mass of 150.71 and multiply that by 100 to make it a percent. So we take 118.71, divide that by 150.71, multiply it by 100 to get a percent, and we get 78.77%. We can then do oxygen next. So we know that there are 2 atoms of oxygen, so we multiply 2 by the mass of oxygen, and we divide that by the total mass of 150.71. So let's type that into our calculators. Let's divide that by 150.71 and multiply by 100 to make it a percent. And we get a percentage of 21.23%. We can always check our work because 78.77 and 21.23, those percentages equal 100%. Okay, for this next problem, what I want you to do is pause the video and try it on your own. The problem says the anti-caking agent in Morton salt is calcium silicate, CaSiO3. Calculate the percent composition of calcium, silicon, and oxygen in calcium silicate. So we want to do calcium, silicon, and oxygen. We want to find the percentage of each of those in calcium silicate. So pause the video and try that on your own. I got a molar mass of calcium silicate to be 116.17 AMUs. So that's our total that we're going to use for this problem. So for calcium, there's only 1, so we just take the mass of calcium, divide it by our total mass of 116.17, multiply that by 100 to get a percentage. So we get 40.08. Divide that by 116.17, multiply it by 100, and we get 34.50%. For silicon, again, there's just one of them, so we just take its mass, 28.09, and divide it by the total mass of 116.17, multiply it by 100, and we get 28.09 divided by 116.17, multiply by 100 to make it a percent, and we get 24.18%. Finally, for oxygen, there are 3 oxygen atoms in this compound, so we would take 3 times the mass of oxygen, divide it by the total mass of calcium silicate, and multiply it by 100. So we get 3 times the mass of oxygen divided by the total mass of calcium silicate. We multiply by 100 to make it a percentage, and we get 41.32%. And if we added all of those percentages up, we would get 100%, which is just what we would want.